Alright, on this video today is Wednesday, March the 7th. We have the specification for the bipolar board, part number CB47417, and we have all the different components that make this configuration unique. The only thing that right now we're using with decade box, it's the 400 kilo ohms, I'm sorry, across the RN8 resistor. But as far as the rest of the components, all of them have been implemented on this particular board. I must point out that the way it is set up, which is basically as requested by the customer, there's three issues. The first is that the delay angle range is 9 to 134 without a polarity transition. 0 to 5, it's 134. So we would be forced to adjust it because the request is for the regeneration angle to be 135 degrees. And this is part of the first question. The good thing is that the span and the bias are installed in sockets, correct, Tony?
Yep.
This board? Alright. The second thing that we're going to prove is what happens when we switch the polarity. What is the value of test point 1, and the DC value of test point 1, the output of the buffer amplifier, will indirectly tell us what our delay angle is when we are transitioning. This will be done in a second video. And we also want to point out that RX, again, our decade box right now of close to 400K, this is the resistor that has to be trimmed to verify a symmetrical response, will be tuned in if necessary. We don't see right now an effect until we know the frequency at which the P signal toggles between 12 volts and ground. We want to verify that this is done in steady state to make sure that whatever value we choose for RX, we're calling it RX, does the job. So let's go ahead, and what we're going to do right now is show the board. It's up and running, SIG highest maximum. And what Tony is going to do is he's going to switch polarity. What polarity do you have, Tony, right now?
Right now we're low, so we're going up.
We're going to go high. All right. So go ahead and switch. All right, there it is. So what we have is the P signal starting low, going high. Test point 8 being basically the same as test point 8 being the same thing as PD, but with a delay. And this is coming later on. Usually these are the complement of each other. I'll just have to check where Tony is picking it up from. But there's the P and there's TP8, and here we have the enable inhibit. Tony commented that if we go, let's move this marker right here to this. It's approximately 24 milliseconds. So I think that before we finalize this, we want to make sure that we fine-tune the transition with a P in steady state toggling at the specified frequency by CONSARC. Keeping in mind that this will not change. Now let's go ahead and switch polarity. Alright, and again, we'll notice that, well, now this particular case, I can see where we will have to fine-tune this, because this delta now, from the time that P is changing, it's 23.5 milliseconds. It's close, but we think we can do a better job. One thing we don't show here is what happens to TP1, so we're going to use another video to do that. I think at this point we're ready to just fine-tune it to make sure that we get those numbers on steady state, as long as we get the transition on P. This is the end of this video.